Hey there, this is Mr. Wilfert, and I wanted to quickly go through Chapter 5, Section 8 here with you, applying special right triangles. This is the last section of this chapter, so we're wrapping it up here with some special right triangles. A couple of things as we go through this, just to remember some of the things that we've talked about with the Pythagorean theorem and the different properties of triangles as well. You want to kind of keep all those things in mind as we go through this. As we go through and we talk about these right triangles, keep in mind that these are special right triangles, and so these things don't apply to all different kinds of triangles. So be aware of that. Try to keep that in mind. The first theorem that we have here is the 45-45-90 triangle theorem. And basically what it's doing is it's comparing some of the sides of the triangle. It says both legs are congruent and the length of the hypotenuse is the length of a leg times the square root of 2. So basically we have these two legs that are going to be the same length. They're both congruent. And this side, this hypotenuse here, this blue side from A to B, is going to be the length of one of these legs times the square root of 2. And so using that property there, you can take a look at different kinds of problems like this where you want to be able to solve for x. So knowing that this side is 7, this is 45, that means this has to be 45 because remember that the angles added up would be 180. So then solving for x here would be 7 times the square root of 2. So that's just one quick example there. Here's another example, a B example. We're taking, they're giving us the hypotenuse is 3, and we need to be able to solve for x, which is the side of the leg. So we can take and set this equation up, 3 equals x times the square root of 2, and then solving for x, we get 3 over the square root of 2, or 3 times the square root of 2 divided by 2. Again, it's fine to use a calculator here and come up with decimal answers for these problems. Here's just an application problem following the same kind of format, the same rules here, same theorem, 45, 45, 90-degree triangle. And then we kind of look at another situation here where we have a 30, 60, 90 triangle. And we can use an equilateral triangle to find a relationship between the lengths of the sides. Again, notice that we're using the Pythagorean theorem here. In this example, notice that we're talking about a 30-degree triangle, a 60-degree triangle, and then 90 degrees, of course. And if you look at the bottom part here, we're saying that y, which is this side here, this is one of the legs, is equal to x times the square root of 3. So we're looking at the shorter leg of that right triangle. So let's take a little bit closer look at that. Here's a theorem, a 30, 60, 90-degree triangle, right triangle. It says the length of the hypotenuse is 2 times the length of the shorter leg, and the length of the longer leg then is the length of the shorter leg times the square root of 3. So we have our one side here. Again, keep in mind this is a 30, 60, 90. We have one side, one leg is S, the length of S, and then the hypotenuse is going to be 2 times S, and then the longer leg is going to be S times the square root of 3. And again, you can use this theorem in a couple of different examples here. Here we're trying to find the values of x and y. We notice this is a 30, 60, 90. So knowing the hypotenuse, then we can actually go through and find the other two sides of those. So take a quick look at that example. The last thing I wanted to quickly go through here is make sure that you take a look at these student-to-student suggestions here. This is kind of a neat idea here on how to kind of simplify some of these things. If you have any questions, please let me know. Thanks.